Today, I'd like to look at trig substitution again, this time with a different trig function. Previously, we did one with tangent. So let's look at another example and see if we can reason out what the trig function should be. So let's say we were taking the integral of square root of 25 minus w squared over w squared with respect to w. Okay. So thinking of our trig identities over there, those Pythagorean identities, remember, first of all, we'd like that 25 to be out of there, right? The constant in all those identities is 1. So just like before, we'd like that to be the square root of 25, so it'll factor out when we put it in. So what are we going to have? When the 25 comes out, we're going to have 1 minus a trig function squared. And if we look at our identities, the first one there, sine squared plus cosine squared equals 1. You could solve that for either sine squared or cosine squared. So you could have 1 minus cosine squared equals sine squared, or 1 minus sine squared equals cosine squared. So either one would work. So this could either be 5 sine or 5 cosine. And like before, where it could have been tangent or cotangent, typically the examples you'll see, they won't use the cofunction. But you could just as easily use cosine. All right, so we need our differential as well. So dw would be 5 cosine theta d theta. And now just rewrite our integral. We've got the square root, 25 minus 25 sine squared. Now, there was another w in here, and that really has nothing to do with our decision. Our decision to use 5 sine really had to do with this binomial here. We're trying to get around that square root by having a perfect square. There can be the variable can appear other places as well. It really doesn't affect what you decide for your substitution. So w was 5 sine, so squared would be 25 sine squared. And then dw is 5 cosine theta d theta. Okay. So what? We want to get that constant out of there, so factor out the 25. Square root of 25 is 5. But we also have another 5 out here, so we've got 25 on top and 25 on bottom. That goes away. So we have sine squared on the bottom, and then cosine theta d theta. And now we have exactly what we wanted. We have the Pythagorean identity, so we can rewrite that as cosine squared. And now we have that same issue that we did with tangent. Square root of a square is the absolute value. So really, when we simplify that, it should be the absolute value of cosine. But again, this substitution is hiding the fact of what theta is really being defined as, because it's written in terms of the original variable. So this really means that theta is sine inverse of w over 5. And again, much like the tangent situation, because we have to limit domain in order to invert that function, theta can only be certain things. And those certain values happen to just be when cosine's not negative. So again, we get lucky, and we don't have to worry about the absolute value. So the square root of the square will cancel off. Absolute value can go away. So we'll have cosine times cosine over sine squared. So we have cosine squared over sine squared. which is just cotangent squared. And if you remember from our powers of tangent, and remember cofunctions work the same, so we want to use actually the Pythagorean identity. That was how we handled powers of tangent. So from our identity, cotangent squared would be cosecant squared minus 1. And remember from Calc 1, derivative of tangent, secant squared, derivative of cotangent, negative cosecant squared. So this is negative cotangent theta minus theta plus a constant. Now we have to get back to the original variable. We want to express this in terms of w, not theta. So again, like we did in the tangent example, we want to draw our right triangle. From that substitution, we want to draw a triangle that represents that scenario. So what do we have? We have that sine theta is w over 5. So we draw our right triangle. Sine is opposite over hypotenuse, w5, which, using Pythagoras, 25 minus w squared. Again, it's worth pointing out, notice that matches that. Again, that's not a coincidence. That'll happen every time. Okay, so now let's rewrite our answer here. So cotangent, well, tangent would be opposite over adjacent. So cotangent's adjacent over opposite. And we had a negative out front. So negative square root 25 minus w squared over w. And then theta, there's nothing we can do about that. That's not a trig function of theta. That's just theta. So we just use what our definition of theta was, which was sine inverse w over 5. And as always, still have our constant of integration. So, so far we've seen that if you have something of the form a squared plus x squared, we said to try x equal a tan. And now what do we have? We have a squared minus the variable squared. I use w's in this case, but a squared minus x squared. As we saw in this example, you'll end up at your trig identity if you use sine or cosine, but again, we'll just stick with the non-co functions. So we have one more left. What we'll look at next time is what about x squared minus a squared? So we'll look at that one in the next video.